Hello friends, it's just Kaan Alpar here, and in this tutorial I'm going to show you how to create an enemy for a top-down shooter game and also how to create an enemy AI that's going to be able to detect when the player enters its vision. So make sure to watch it until the end to understand how all of it works, and let me explain first of all roughly how we're going to implement this. So at the moment we have the player in the game, which looks something like this, with his little gun. And we also have some boxes, which are fantastic. As you saw, the art for them was amazing. And currently the world is peaceful, there's nothing going on. So we have to do something about that. We have to introduce some, violence into this world, and we're going to do that by creating the enemy. That's going to be the first step. The enemy is going to be a zombie. It's going to have the usual stuff, the collision shapes and blah, 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 the sprite. And it's going to have a couple of interesting mechanics. So the first one is going to be the vision. We're going to do that by creating an area 2D inside of the enemy. And it's going to have a circle collider like the one you see here. And if the player enters this collision shape, the enemy is going to start chasing the player. And if the player then exits it, the enemy is going to stop moving. So very simple mechanic. And this is going to make sure that if we have enemies far away, like here, they're not going to, all of them, they're not going to try to chase the player right away. They're going to wait until the player is in range. So that's the first mechanic of the enemy. Very simple. The second one is going to be their ability to unalive the player. And we're going to do that in a very simple way. Simply, if the enemy touches the player is going to lose the game. And to do that, we're also going to create an area 2D in the player called the hitbox, which is going to be, its purpose is going to be detecting if the enemy is touching it. And we're going to make that a separate collision shape because then we can control how big the hitbox is, which is going to influence how difficult the game is going to be. Okay, perfect. So that's about it. We're going to do a bunch of cool stuff like, let's see, calculating how far away the enemy is from the player, calculating the direction from the enemy to the player so that we can make the enemy move. So there's a bunch of cool stuff in this lecture, in this tutorial. So make sure to watch it until the end and let's get to work. So let's go ahead and start by creating the enemy scene, which is going to be a character body 2D, just like the player. We're going to call it the enemy and save it inside of the scenes folder. If you're planning on having multiple enemy types, it probably makes more sense to call this the zombie, and then you can have different named enemies. But in this case, we're just going to call it the enemy. Let's create a sprite here and also a collision shape 2D. For the sprite, we're going to use zombie.png, scale it up by 3, just like we did with the other sprites. So it's going to look like that. And we're going to create a capsule collision shape, just like the player, because they're very similar in how they look like. So maybe something like that. Perfect. And now we're going to create the area 2D that's going to detect the player. We're going to call this the player detector. It's going to have its own collision shape, which is going to be a circle. And we're going to make it large like that. So the bigger this is, the more vision the zombie has. And this way, the zombie is going to know even if you're behind the zombie. So you might want to turn this into actually like a polygon if you want to. That way you can create like a triangle in front of the zombie, and then you can basically sneak past the zombie if you're behind of it. But this is the way I want to do it. My zombies are slightly more intelligent, I guess. So they know if there's something behind them. So that's how that's going to look like. Let's go into the world and put one of these just to see what they look like. And we can actually go into the debug menu here and turn on visible collision shapes. That way we can actually test this a little bit easier. Okay. As you can see, that's what that looks like. Perfect. And I also want to go into the player script real quick, and I want to make it so that when I press the quit input action, I want the game to stop. So I'll just do that real quick. Just like that. Just a quality of life thing for me. And then we're going to actually go into the player scene again, and we're going to create the hitbox for the player, which is going to be an area 2D. Let's call it the hitbox. It's going to have a collision shape. And if the enemy touches this collision shape, we're going to lose the game or lose a hit point or something like that. And this is going to be a capsule again. And the larger this is, easier it's going to be for the enemy to hit the player. So it's going to control the game difficulty in a sense. So up to you. I'm just going to make it slightly smaller than the collision shape of the player. But that's going to bring up a problem. How is the enemy going to touch the hitbox if the collision shape of the player is larger? So we can actually connect the body entered signal of the player, of the hitbox, to the player script. So let's just double click on it. Connect it. And then here we can just print touched the player. If we play the game, let's see, something touched the player. That wasn't the enemy though, so don't worry. As you can see, the enemy can't touch the hitbox because we're colliding with the enemy. So we need to determine in our game what collides with what. And to do that, we can use the 2D physics layer system, which I'm going to explain briefly. I'm not going to get too detailed with it. So if you click on any collision shape, like any physics body here, you will see that it has a collision tab. And in here you have layers and masks. Let's say that this is on layer 1 and it's looking for the mask is also layer 1. So we are on layer 1 and we're looking for other, physics bodies or areas to collide with that are on layer 1 as well. If you put this to be layer 2, the mask, now we're looking for things to collide with on the second layer. So if there's something on the first one, we're not going to collide with it. And we're going to have multiples of these as well. We're going to, we can be on layer 1, 2, and 3, and we can look for collisions with 3, 4, and 5. Okay, so we can use this system to determine which object collides with what, basically. And we're going to give these names to make that a little bit easier. So let's go into the project settings, into 2D physics, and in here we can name these layers. So the first one is going to be the world or the environment. So this is going to be anything like the boxes we have, any other objects like a prop that we might place down. It's going to be on the first layer. The second one is going to be the player. The third one is going to be the player's hitbox. After that, we're going to have the enemy. The enemy is not going to have a hitbox. We could create a hitbox for it, but we can get away with not having one. So I'm just going to do the easier thing here. And then we're going to have the enemy's player detector. So we have all these different types of objects, and now we're going to determine how they interact with each other using the layer system. So for example, for the hitbox of the player, we're going to place it on layer 3, as you can see, which is the player hitbox. And the player hitbox is simply going to check for collisions with the enemy. That's it. So we're going to have the mask set to be 4. Let's do it for the player as well. So click on the root node, the character body, go into the collision, and there's 2 of them here. So the one in the bottom is going to be the right one. So the player will be on the second layer, and it's going to look for collisions with the environment and also with the enemy as well. Let's see. And also the enemy player detector. We'll also try to check with that as well. Okay. So let's go into the box, for example. And the box is going to be on layer 1. It's part of the environment. And it's going to check for, let's see, with the player and with the enemy. Yeah, that's going to be all for the box. And for the enemy, we have the enemy itself, which is going to be on layer 4. And this one is the collision shape of the enemy, right? So we don't want this to collide with the player. We want this to collide with the environment. And let's see, anything else? Other enemies, yeah, why not, maybe. Okay, that's going to be all. And for the player detector, it's going to be layer 5. And this will check for the player only. Okay, did I do all of that correctly? Hopefully. So the player here actually is not going to collide with the enemy. I made a mistake here, so go into the player and for the root node, make sure it doesn't collide with the enemy. Because that's the problem we're fixing. Remember, the collision shape of the player is too big. So if we're colliding with the enemy is not going to be able to touch the hitbox. Okay, perfect. So now we should be able to play the game. And as you can see, the enemy can touch the player. Perfect. Okay, so that fixes that problem. And we'll obviously want to check in here if this is actually the enemy, because it might be something else. So to be able to do that, we can actually just go into the enemy. We can create a script. Let's create the script. And in the script, we can use a class name keyword and give this class a name, which is going to be enemy. When you use this keyword, now you can use this enemy keyword here as a type to check if a variable is of this type or not. Let me show you how to do that. So in the player, we can say if body is enemy, only then print this. So body here is what the hitbox collided with. It's a physics body, but we don't know if it's the enemy yet. So that's why we do this check. And if this if statement is true, then it's definitely an enemy. So now it's going to look exactly the same. But now we know for a fact that it's the enemy. So if we were to touch other stuff, if we had other stuff that we could touch, it wouldn't say touch the player. And obviously here we don't want to say just touch the player. What we can do for now is we can basically, let's actually emit a signal. I'm going kind of out of order with this lecture. I meant to do the enemy first, but I'm doing all this stuff, but it's okay. It's gonna come together as we continue. Just trust me. So we'll create a signal called died, and we'll just emit the signal here. We'll say died.emit. And we can also queue free the player, so we'll just get rid of the player. And in the world, then what we can do, we can create a script for the world. And in here, we'll just take a reference to the player. And in ready, we'll just, let's see, that's going to be lowercase. We'll just connect the died signal to a function here. Let's call that onPlayerDied. And in here, we can just print game over. And then we'll restart the game, which we can do by calling getTree reload current scene. But we don't want to do it immediately. We want to do it after a delay. So we'll just say getTree again, create a timer for 3 seconds. And let's take the timeout signal of that timer and let's connect it to this function right here. So make sure to get rid of the parentheses at the end there, just like I did. We're simply taking the timeout signal of the timer that we created just now and telling it to call reload current scene after the timer is timed out. Okay. Hopefully that's all making sense. So now the enemy should be able to kill the player. Let's see. As you can see, the player goes away. It says game over. And in 3 seconds, we're back, baby, we can play again. But as you can see, there's a slight issue with this, and that is when the player gets deleted, the camera is also deleted. So we have to fix that as well. And we're going to do that using a camera, a remote transform for the camera. So go into the player and create a remote transform 2D. And this is a very simple node that takes its own transform, its own position, and pushes it to a different node. And you can specify what that node is. So in this case, it's going to be a camera that's in the world scene. And that camera is going to take its position from the player's remote transform. So even if the player gets deleted, the camera won't be deleted. It will still be in the world scene. So we'll just call this the camera remote transform. And as you can see, it has a remote path. This will be the path to the camera node. And we're going to set this from the world script. Before we do that, in the player script, we'll just create a reference to this. Let's say onReady var camera remote transform. Just like that. And then we can go into the world script here and use that. So we're going to, let's say, we're going to create a camera here in the world, and we'll call this the main camera. And then we're going to create a reference to it, probably. Main camera. Just like that. And after we connect the signal, we can just say player camera remote transform dot remote path. So remote path is going to be this property here that we need to set. So that's going to be the main camera.get path. So this is going to make sure that the camera we have here in the world, which is right here, it's going to get its position from the remote transform node in the player. And that's going to create the same effect we had. So the camera is going to be on top of the player exactly. But now, if the player gets deleted, the camera is still there because if you take a look at the remote tab here, you'll see that the camera is here in the world. Let's see, where is the game? Here it is. Okay. And if I lose, you'll see that the camera is still there, but the player just got deleted. So that's how that works. Hopefully this is all making sense. We did everything besides working on the enemy up until now. So next up, let's make it so that the enemy actually moves towards the player when the player is inside of the player detector. And also, we're going to do a bunch of other cool stuff as well. So let's get started with that. Okay. So the way the enemy is going to work is going to be similar to the player in terms of its movement. Let's also create the process function. Okay, and let's also connect the player detector's signals. The first one being body entered, and the second one being body exited. So in the body entered function, we're going to detect if it was the player that entered the player detector. And in the exited, we're going to determine if it was the player that exited. And in both cases, we're going to set the player variable, which is going to be up here. So this is very important for the enemy because the enemy needs to know where the player is to do anything, basically. So we're going to create a variable to store the player. And I'm going to go into the player script and use a class name here as well, because we're going to have to do something similar. We're going to have to check if something is the player or not. So we can also say that this player variable can only be a player type. So that's how you do that in Godot. You put a colon, you give the type. So now this variable can only be set to be a player, nothing else. You can also do it with like an integer, with like a float, whatever. In this case, it's going to be a player. Okay, so first of all, let's do the detection. So if something enters, a physics body enters the player detector, first we'll check if that's a player or not, and if the player variable is null. If both of those are true, we can go ahead and set the player variable to be the body, which is the thing that we collided with. And we can just print something here, and we can say name plus found the player. Name here is the name of the enemy, found the player. Very simple. And we can do something very similar down here. If something exited the player detector, was that the player? Is the player not null? So do we have a player at the moment? If so, the player just left the detector. So let's just say it's null now, and name lost the player. Okay, so this should be working. So let's give this a try. Now I should be able to enter here, and enemy will say enemy found a player, and when I get out, enemy lost a player. Perfect, it's working. So the next step is going to be making the enemy face the player. And we can do that using the lookat function that we used in the player. So in the enemy, in the process, we'll simply say lookat the player global position. But there's an important check we need to make. Do we have a player? So if player is not null, only then we'll try to look at it, because if it's null, then we're going to try to get the position of something null, and that's going to crash the game. So very important that you do this check. Now the enemy should be facing the player, and as you can see, it is. Perfect, we're almost there. The next step is going to be making the enemy chase the player. And to do that, we're going to do a couple of interesting stuff. So first of all, let's say this is the player, this is the enemy, and the player is in the range, so the enemy wants to chase the player. First of all, the enemy needs the direction to the player, and to do that we can simply, let's see, we have the enemy's position here, and we have the player's position here. So to find the direction, to find a vector that's going to look like this, a vector that starts at the enemy's position and goes to the player's position, we can simply take the player's position, PP, and we can subtract the enemy's position from it. And that's going to give us this vector right here. And then we can normalize that, and that's simply going to give us the direction. And then we can multiply that with speed to make the enemy move towards the player at the speed that we want. And one other important thing that we're going to check here is going to be the length of this vector, because we don't want the enemy to try to go inside of the player. We just want it to get close enough to touch the player and stop. So we're also going to check how big, how long this vector is, and stop the enemy if it's getting too close to the player. Okay, so let's implement that. So first of all, I'm going to create some variables up here. Let's say speed. We can make this a float, just like that. And we can set this to be 100 so that it's slower than the player. I'm also going to create a direction here, which is going to be a vector 2. And there's a shortcut for this, by the way. You can just say colon equals, and then it will just infer the type. So if you give it a vector 2, for example, now this variable can only be a vector 2. Okay, so that's the direction, that's the speed. So we're going to use these in physics process. And physics process is going to look similar to what we did for the player, at least the second part, this part right here. And the first part, the direction is going to be different. It's going to be what I just explained to you, because obviously we can't get the direction from the keyboard this time. We need to calculate it ourselves. Go ahead and change the move there here to direction. And we don't have to normalize it here. We're going to do that somewhere else. But besides that, it's going to look the same, just like this. Perfect. So let's get the direction, and let's also do the calculating of the length of it as well. So first of all, before we do that, actually, let's make sure that we have the player. So if the player is not null, only then we'll try to move. Next up, we're going to find that vector from the enemy's position to the player's position. We can call that enemy to player, just like that. And that's going to be player.global position minus global position of us. And then we can actually check, let's see, we'll do the length later. Then we can simply say direction equals enemy to player.normalized. And with this, the enemy should be moving towards the player. Let's give it a go. And it is working, as you can see. Obviously, it's not very smart, it's kind of dumb, so it's not going to be able to get over like a box like that, but that's something we can fix later, step by step. But as you can see, it's working, and if I get out, it's going to stop. Get in, get out, get in, get out. Perfect. But the problem is going to be, well, now there's no problem because we die in one hit, but if we were not dying in one hit, let's actually stop the player from losing the game. And let's see, pass, okay. You will see that the enemy just tries to get alarmingly close to the player and it goes into a crazy rage like that. So to prevent that from happening, what we're going to do is, before giving the direction to the player, we're going to check the distance between the enemy to the player. And to do that, we can simply say enemy to player, which is this vector right here from the enemy to the player, like I said. And we can just say dot length. And that's going to give us a float like 50 or 80 or 100. And that's the distance. And we can check that. So we can say if enemy to player dot length is, let's say, greater than 50. Only in that case, set the direction to what it's supposed to be. And else we can say direction is 0. So we can actually make it even larger to see the effect easier. Now, as you can see, the enemy tries to get close, but if it's closer than 100, it stops. But of course, 100 is too much. It's never going to be able to touch the player. So it probably needs to be like 20. And what I'll do is I'll just turn this into a variable. So we'll just say stop distance. And we'll set this up here to 20, which should be good enough. Yeah, that's good enough to touch, probably. Let's turn it on. Yeah, that's good enough. Okay, perfect. And now the game is going to restart as well. Awesome, so we have an enemy that follows us when we get inside of their range. And they actually stop without getting too close to us, and they can touch us and they can make us lose the game. So perfect. Awesome. Okay, so that's going to be it for this one. Make sure to watch the next one to see how I'm going to implement the shooting of the enemies, which is going to be awesome. But yeah, I'll see you in the next one.